Good afternoon. Right now we are standing on the spotted granodiorite exposure in a small hillock at the same location like yesterday, 1.5 kilometer southeast from the village Kersai. And here one phenomenon we have noticed, we want to explain that one. You can see due to fracturing, you can see some aperture space is there between two granodiorite bodies, and within that two shear zone has passed. One is along this direction. You can see the stretching of the quartzo-feldspathic mass, and here also the same, the stretching ellipsoid sigmoidal. This one is sigmoid shaped with top to right sense of shearing. This kind of sigmoid shaped quartzo-feldspathic mass are present. But the thing is, many people used to explain that this kind of phenomenon happens for spheroidal weathering due to that onion skin peeling off. But the thing is, a spheroidal weathering cannot change the shape of the quartzo-feldspathic mass in such a way. One prismatic quartzo-feldspathic mass can be chemically weathered or mechanically weathered to an elliptical mass. It can become a slightly rounded, but it cannot be shaped as sigmoid. For that you need some deformation, you need some force, and you can see here, if you look closely, that along the margin these shear zones are also rotating. The shear zones from here up to this direction, by encircling this whole body of granodiorite, the shear zone is also rotating. So how to explain this kind of phenomenon? Because from my first year of field work, I am hearing from many seniors that it is the result of weathering and erosion and spheroidal weathering mainly. This kind of things happen. But logically it is not possible to generate a sigmoid shape quartzo-feldspathic mass from a prismatic shape initial prism of quartzo-feldspathic mass. So for this, a ductile deformation is the only explanation that has happened, and since that has happened and that only can generate a sigmoid shaped quartzo-feldspathic mass or sheared mass, so what could be the explanation of these shear zones? Another thing for explaining this phenomenon or interpreting this phenomenon, another clue is very important. These shear zones are limited in extension. Suppose this shear zone, if we trace it, here it is dying out here. It is dying out here. Please come here. And if you look in these locations, here is another shear zone passing. Another shear zone. These are the weathered part, and these are the stretching of the feldspar. And again, if we move upward, we can see another shear zone, small, with very limited extension. Now these are solid state deformational product. That is why in ductile regime, solid state deformational product these are. So to explain this, I think from my experience, generally we used to see this kind of batholith standing in agricultural land granitic batholith. We all have seen. So if we think in that way, suppose this is a magma chamber and here these are the solidified mass of granodiorite or granite, and when next stage of melt, suppose these are already solid. This is a granite pluton where 50% is solid, has solidified, and 50% is still in melt stage. Suppose these are the solid patches of granite, and this buoyant melt is upwelling from this direction. So if we zoom in, these are two granite bodies, or suppose this is a single granite body, and along by fracturing it, another phase of solid plus liquid is upwelling. So here it is solid, here it is semi-solid in this channel. So there will be a torque, or there will be a shearing, and this kind of shearing can give rise, because it is already semi-solid. In some semi-solid state, ductile flow is very much possible, and this kind of thing can result formation of sigmoidal masses. But these shearings are not due to crustal scale continental plate movement or any oceanic plate movement. These are not due to that. These are due to these are all primary shearing, but not due to crustal scale deformation. So in this way, I think this could be one possible explanation for getting such limited extension small shear zones. This should not be explained, as per my observation, this should not be explained as the product of weathering and erosion, because weathering and erosion can give rise to suppose this is the feldspar prism. By weathering, this can be turn into this, but it cannot turn into such structure. For this, you need to have shearing, and if semi-solid mass move along a solid mass due to flow, there can be shearing very easily, and due to gradual reduction of temperature, when the whole ensemble cools properly and become 90% and above solidified, then the existing deformational features got already imprinted on that, and in that way we can find such thin shear zones in granitic terrain. We should mark it as primary shearing, not secondary shearing, and on the other hand, we should not call that due to spheroidal weathering either. Thank you.